All right, here we go, guys. Exponents and logarithms. At this point, we've looked at several different types of functions. We've looked at linear functions. We've got quadratics. We've got absolute values, square roots, exponentials. We're going to add one more to the list, and that's logarithms. Today, what we're going to do is just kind of give you a brief introduction on what a logarithm is and what it looks like. So it's going to be very basic today, and then tomorrow we'll get a little more in detail about those logarithms. All right, so if you notice at the top of your paper on the left-hand corner there, you see a graph. That graph that you see is the graph of the exponential function y equals 2 to the x power. What we want to know is for what value of x is the function equal to 20? Or in other words, what exponent can we use on the base 2 so that we get an answer of 20? So what we're really trying to do is we're trying to solve this equation 2 to the x power equals 20. What can I replace x with so that the answer I get is a 20? Well, there's a couple of different ways that we can find that answer. And the first thing we're going to do is something called trial and error. We're just going to try some numbers and see what will get us to that 20. So for example, 2 to the second power. Is 2 to the second power going to give me a 20? No. What is it going to give me? 4. That's not what I'm looking for. I'm looking for a 20. So let's try something else. Let's try 2 to the third power. Is 2 to the third power going to give you a 20? No. What it's going to give you is 8. That's not what I want. I want a 20. So let me try something else. Let me try 2 to the fourth power. Is 2 to the fourth power going to give us a 20? No. No, it gives you a 16. Notice we're getting closer though. What about 2 to the fifth power? 32. 2 to the fifth power is not going to give you a 20. It's going to give you a 32. Now, do we really need to keep trying other numbers, 2 to the 6, 2 to 7, 2 to 8? No. Why? Because they're going to end up being bigger than the 20 that we're looking for. So right now, from what we've tried out so far, this exponent that we're looking for should fall between what two numbers? 4 and 5. It's going to fall somewhere in this area here. So let's see if we can get a little closer to that 20 than a 16 or a 32. So let's try, I don't know, let's try 2 to the 4 point something power. What do you think? 4 point what? 4.2. Let's try it. 4.2. Is 2 to the 4.2 power going to give us a 20? Well, what do you get? 18 point something, which is definitely closer to 20 than the 16 was. Let's try something else. Let's try 2 to the 4.3 power. What is 2 to the 4? Say that again? 19.6. Well, that's a lot closer to that 20. And then we could keep trying and trying and trying until we get to that 20. So, for right now, we're going to call 4.3 the solution. Now, depending on what we're working with, that might be good enough. 4.3 might be good enough for an answer, depending on what we're working. But there are other methods that we could use to find this 20. We can also try using a table. So that's what we're going to try next. We're going to see if we can get a little closer to 20 than that 19.69 that we have so far. So let's do this. Go to your calculators. I tell you what, reset your calculators first. Do the second plus 712. Second plus 712. Once you do that, then go to y equals, and let's type in that function, 2 to the x power. So y equals, and type in 2 to the x power. Now, if you go to your table right now, it's not going to do a whole lot of help for us because all you're going to see is the 1, 2, 3, 4, 5. What we want to see are some decimals. So what I want you to do is go to second window. I think that's what it is, second window. And we're going to adjust the table setup. What we're going to do is we're going to count by hundreds. We're going to go 2 decimal places instead of just 1. So where you see the little triangle and then table next to it, we're going to change the 1 to a 0.01. Change that to a 0.01. So we're going to go by hundreds instead of just by ones. All right, once you change it, we're going to go back to the table, and we're going to look for something in between 4 and 5. We're trying to get as close to 20 as possible. Now, some of you are holding your finger down until you get to that 4, between 4 and 5. There is a faster way of getting there instead of just holding down that down arrow. Anybody know how you can get there faster? There you go. Go to the second window, and where you see that table start, just type in where you want to start it. And I would suggest something like a 4 or a 4.3, something like that. Okay, so let's take a look at the table that you see on your calculator. You should be looking at something that looks very similar to what I have here. Notice we've got 2 of those that come real close to 20. We've got 4.32. That's real close to 20. It's 19.973. And we also have 4.33. That's also real close to that 20. And it's 20.112. So the closest thing we have is 4.32. So notice it's a little closer than what we came up with in the trial and error method. But is it the exact answer? Is it what exactly gives me a 20? No. So again, depending on what we're working with, it might be good enough for an answer. We might want something even closer. We want the exact answer. So, is there another way we can find the answer? Yes. We can also use graphing method. So what exactly am I going to do for the graphing method? Well, we're going to graph the equation. So right now when y equals in y1, you already have the exponential 2 to the x power. But I also need you to type in something into y2. So go to y2, and I want you to type in the right side of the equation. What do I have on the right side of the equation? I have a 20. So type in a 20 for me. Then I want you to hit graph. And if you did everything I said, you should see 2 things. You should see a graph of your exponential. That's going to be the curve graph. And you're also going to see a horizontal line. Can you see those 2 things? A curve and a horizontal line. You don't see the horizontal line? You want to know why you don't see the horizontal line? Because of your window. Your window is not set up correctly. That window is only going from a -10 to a +10 right now. Remember, the number we just typed in is 20. So we've got a horizontal line going through 20. So we need to change our y maximum. So go to your window, and we're going to change the y maximum to something that's bigger than 20. So you can use something like a 25 or a 30, as long as it's bigger than 20. And really, that's the only thing you're going to have to change in order to see the correct graph. So once you change that, go back to the graph, and you should be able to see both things now. The curve, the exponential, and the horizontal line. So the question is, what exactly am I looking for in those 2 graphs? I want the solution to the equation, but the intersection. We want to know where are these 2 lines or these 2 graphs intersecting at. So how do you find that point of intersection? The calculator will do it for us. Second trace, number 5. Then you're going to have to hit enter 3 times. Enter, enter, enter. And what do you notice down there at the bottom of your screen? Yeah, and doesn't that look pretty close to those numbers that we were coming up with earlier? So if I want the exact number, it's that real long decimal that you see down there at the bottom of your screen, which is 4.3211 9 something, something, something. That's the exact decimal that's going to give me that 20 that I was looking for. So the 3 methods that we tried or used to solve this equation was trial and error, using the table, and using this graph. But usually when you solve an equation, there's a 4th method that we do, and it's the one that we use the most often, and it's algebraic. So the question is, can you solve that equation, 2 to the x power equals 20? Can you solve that algebraically? Well, the answer is yes. Of course, the knowledge that we have up to this point, we really don't know how to do that just yet. So I'm going to show you how we can do some things to solve this algebraically. But before we do that, let's go back and remind you of a couple of things here. First of all, you'll notice that the first operation we're dealing with is addition. How do you undo addition? How do you solve an equation like this over here? N plus 4 equals A. How do you, what? You subtract. The opposite of adding is subtract. So in this particular case, we would take our answer, subtract 4 from it, and that would give us the answer to the variable, solving for the variable. So in other words, to undo addition, we got to use subtraction. So then the next question is, what if we have the operation multiplication? How do you undo multiplication? You divide. So in this particular case, we would take the A divided by 3, and we would solve for that variable. So to undo multiplication, you gotta divide. We do the opposite. What's the operation in that next equation? N squared equals A. The operation we're working with is squaring. Anybody remember the opposite of squaring? Square root it. Very good. Square roots. So in other words, to undo square, you've got to take the square root. So when we're solving equations, you always need to undo things. You do that by doing the opposite. The opposite of multiplying is divide. The opposite of adding is subtract. The opposite of squaring is square root. So then what's the opposite of exponent? How do you undo an exponent? Well, I'll give you a hint. Look at the title of our paper. There it is. The opposite operation, or the opposite of our exponents, is going to be logarithms. That's what we're going to be looking at today, logarithms. And in this particular case, it's going to look something like this. And we'll talk about what that is and how we read that in a second. Now be careful when you write that down. Notice that 2 that you see there is subscript, meaning it's in the bottom right-hand corner of your G. Small 2. Not a normal case 2, it's a lower case. So again, the bottom line here is the way we undo exponents is to use logarithms. That's what we're going to be using, logarithms. All right, that takes care of our first page. We're halfway there. Let's take a look at the next page. On the next page, they've given you the graph of our exponential. That's the graph of y equals 2 to the x power. Now, what we found out yesterday, or what we should have found out yesterday on that assignment that I gave you, is that exponentials and logarithmic functions are inverses of each other. They're inverses. And y'all still remember what an inverse is, right? What is an inverse? There you go. It's when you switch the y and the x. So what we're going to do is we're going to generate a graph of our logarithmic function simply by switching our x and y coordinates. So we're going to switch the x and y coordinates of our exponential so that we can take a look at the graph of our logarithmic function. So notice they got us started over here. They gave us the graph of the exponential. They took a couple of points, these points right here, and they put them in the form of a table. That's this table right over here. What we're going to do is we're going to find the inverse of that table. In other words, we're going to switch the x and the y values so that we can graph the logarithmic function. So let's start by switching all the x's and the y's. So this first order pair is going to go from being -2, 2.5, to 2.5, -2. We're going to switch the x and the y. We're going to do the same thing on every single one of these order pairs. So go ahead and do that for me. Switch all of your order pairs. What I want you to do is after you switch those order pairs, I want you to take the new order pairs that you just created, plot them on the same graph paper as our exponential, and let's see what the graph looks like. So take the new order pairs, plot each one of those points on your graph, and let's see what the graph looks like. When you get all the dots, go ahead and connect those dots. All right, so this is the graph that we should be getting. All we did was switch the x and the y values. We plotted the new points, and this is the graph we get. Notice this graph should look familiar to you guys. You saw this graph yesterday. It was the very last graph that you got on your worksheet. It's what we got when we switched our x and our y values. Okay? So this graph that you see here in red is the graph of our logarithmic function. Now, we just said that inverse is when we switch the x and the y. But we also talked about graphs and their inverses. Do you remember what we said about their graphs and inverses? What kind of transformation just occurred here? A flip. What do we call a flip though? A reflection. Okay, so the next question is, you're right, there's a reflection. But where? Where did that reflection occur? Over what? Sure. There is a reflection, but it's a little tricky here. Where is it? Linear function. Okay, but where is it? Where's that line? There it is. Yeah, good. It's that diagonal line, guys. It's the one that goes from one corner to the other. It's that line, y equals x. So draw that for me on your paper. What we're getting is a reflection over that dotted line. This exponential that we started with is being reflected across this dotted line, which is giving us this new graph called our logarithmic function. This is why we call them the inverses of each other. They're reflections over that line y equals x. All right, very good. You remember. All right, so let's take it to the next level. How do you write and read logarithms? What do their symbols look like? Well, here's the exponential. Let's start with this b to the x power equals a. If b to the x power is equal to a, then log something something equals something. All right, let's start with the little dotted box here. What goes in the little dotted box? The b. B goes in that little dotted box. And what is that b? It's the base of our exponential over here. It's the base. Next thing we've got to decide is what goes inside the parentheses. Nope. The A. The A goes inside the parentheses. We call that the argument. What is it going to be equal to? Well, there's only one thing left, and that's the x. And what is the x called? What is that x called? What is that little number on the top right hand corner? There you go. It's called the x called. Okay, so we got this log with a little b, then an a in parentheses, equals x. Now the question is, how do you read that big old mess there? How would you read that? We don't say log b a equals x. That's not how we read that. How do you read that? Here's how we do it. The way we read that is log base b of a equals x. Log base b of a equals x. In other words, what power goes on b to get a? Now, don't forget, guys, the reason we're using these logarithms is so that we can undo our exponents, so that we can isolate those exponents. This is why we're using those logs, so that we can undo the exponents. Now, as I mentioned at the beginning, today we're keeping it very, very basic. We're not doing anything fancy here today. As a matter of fact, the assignment that you're going to be getting here in a minute is going to look a lot like this last section of our notes. So what we're going to do is we're going to take an exponential and we're going to rewrite it in the form of a logarithmic function. All right, so here we go. You'll notice that A says that 7 squared is 49. Is that true? Is 7 squared equal to a 49? Sure. 7 squared is 49. So if this is our exponential, what does it look like in the form of our logarithm? Well, first thing you need to write down is log. As a matter of fact, let's go ahead and put that in all of these boxes, A through E here. Log is the first thing we need. So go ahead and do that on all the boxes. Log. All right, after you get through writing down the log, we need a little number next or on the bottom right-hand corner of the G. Okay, and that number that you're going to write down is the base. So, on letter A, which of these three numbers is the base? So, 7. So that's the little number that you're going to put on the right-hand corner of your G. Now you need something inside the parentheses. That's going to be our argument. Which one is the argument, the 2 or the 49? What was that? The 49. Very good. That's what goes in the parentheses. Equals. It's always going to equal to the exponent. What's the exponent in that exponential? 2. Therefore, you end up with something that looks like this right here. But the question is, how do you read that? Look at the one we did right before this. How did we say we were going to read that? Log base B of A equals X. So how do we read this one then? Say that again.
Base 7 of 49.
Okay, but we're just going to say of once. Okay, so it's going to be log base 7 of 49 equals 2. Okay? Log base 7 of 49 equals 2. All right, let's do the next one, B. We already wrote down log. What is the little number we're going to put on the bottom right-hand corner of our G? What's the base? 3. Now we need the number that goes inside the parentheses. That's called the argument. What goes inside the parentheses? 243. Good. Equals. Equals the exponent. What's our exponent? 5. Therefore, you end up with this thing right here. So again, how do you read that?
Base 3 of 243.
There it is. Log base 3 of 243 equals 5. All right, next one. 6 to the negative 2 power is equal to 1 over 36. That is true. How do we write that in the form of a log? Well, first you got your log. What's the number we're going to put on the bottom right-hand corner of the G? What's the base? 6. Now we need the number that goes inside the parentheses. That's called the argument. What goes inside the parentheses? Well, what do you see there? 1 over 36. That's what's going to go in the parentheses. 1 over 36 equals, what's the exponent? Negative 2. Therefore, you end up with this thing right here. And again, the way we're going to read that is log base 6 of 1 over 36 equals negative 2. You guys with me? Pretty easy. So then what is the next one going to be? Log base 9 of 27 equals, there it is. Good. So again, it's log base 9 of 27 equals 1.5. Next one, log base what? 4. In parentheses, you have a x equals 9. So it's log base 4 of x equals 9. Now over there on the other side, f and g, they're still the same thing. Hasn't changed. So we're still changing the exponential to a log. So we're going to have log base 2 of 20 equals x. G is going to be log base 8 of 32 equals x. So at this point, we've taken all of the exponentials and converted them into our logarithmic. Can we go the other way around? Can we go from a log to an exponential? Sure we can. So can you guess what this first one's going to be? What's the exponential going to look like? We got log base 2 of 64 equals x. Which one of those is the base?
No,
2 is the base. That 2 needs an exponent. Which of those is the exponent? The x. And what is it going to equal to? 64. So the exponential we end up with is 2 to the x power equals 64. What about the next one? X is the base, good. The exponent on that base? 2. And it's going to equal to a 64. So we end up with the exponential x squared equals 64. And the last one, j there, we have what for the base? 64. The exponent is 2, and it's going to equal to x. So 64 squared equals x. Now the last part down there is a little bit different. We've got something called a common log. A common log. And a common log uses a certain base. And the base they use on that common log is a 10. Common log uses a base of 10. So if you look closely at those logs that we have down there at the bottom, it looks like there's no base on it. Looks like there's not a number on the bottom right-hand corner of the G. But it is there. You just can't see it. And that base is a 10. So, if the base is a 10, what would that first one look like in the form of an exponential?
10 to the power.
All right, very good. 10 to the second power, or squared, equals 100. Is that true, by the way? Is 10 squared equal to 100? Yes. Oh, by the way, does the calculator have a log button? Yes, it does. As a matter of fact, I want you to do me a favor. Go to your calculator, get yourself a clear screen, and I want you to type in for me log. Then I want you to type in 100, and then what does it say? 2. So the calculator says that log of 100 is 2. Why? Because 10 squared is what gives us a 100. What they're giving us is the exponent. Let's try the next one, L. What does that one look like in the form of an exponential? You got it? 10 to the what power? Negative 3 equals x. Very good. 10 to the negative 3 power equals x. By the way, does anybody know what 10 to the negative 3 power is? What is 10 to the negative 3 power? Okay, but you know me, I don't like decimals, I prefer the fraction. What would that be as a fraction? 1 over 1,000. That is correct. 1 over 1,000. By the way, we talked about negative exponents. Can we have negative exponents? No. So what did we do with negative exponents? You remember what we did? Reciprocal. We rewrote it as 1 over 10 to the third power. And what is 10 to the third power? It's the 1 over 1,000. So that's where that's coming from. M. How do I write that as an exponential? 10 to the fourth power equals 10,000. Very good. Isn't that true? 10 to the fourth power equals 10,000. And then the last one, how's that last one going to look? 10. Very good. 10 to the x power equals 1 over 10. So what we're going to be doing today on our assignment is we're going to go from an exponential to a logarithm, or from a logarithmic to a exponential. Okay, so that's all we're going to be working on today. Tomorrow we'll get a little more in detail about these logs.